Welcome to my channel. This is Kingsbury TV. Welcome to another episode. We are looking at linear momentum, and the other day where we look at linear momentum, we talk about momentum, which is the product of mass and velocity. We also talk about impulse, which is the change of momentum of a body, or you can refer to it as the product of force and time. So today, moving forward, we're talking about collision within a brief minute. And just pay attention. Everything I teach you here, they are the cogent things you need to grab in every class or in every topic that I will be teaching. All right. So collision, we want to look at the context of collision. What does collision mean? Now, from the word collide, we can have collision. When something collide, what does it mean? We can still say jam. All right. When something jam, it's still a big grammar. What do you mean? We can still say eat. That is when two things actually eat one another. By the time they come in contact with one another, that is collision. All right, that is jam. Now, because in that process, when they eat each other or jam each other or collide with each other, now that is referred to as collision. Now, if you understand that as collision, it then means that each body or each object has its own mass, and has its own velocity, right? It has its own mass and it has velocity. Now, in this case, when the collision has happened, there is what you call before collision, and after collision. Stay with me. Before collision and after collision, and then you have what you call during collision, right? During collision, or you can call it impact. Now, if you follow to that point, what that means is when, let's take for example, this particular ball is rolling towards this side, and this is also rolling towards this side. Now we can refer to this as, okay, this has 5 kg. For example, the mass is 5 kg, and this also has 5 kg, right? Now, and they are all moving towards each other. But don't forget, their starting point, they will always have what you call initial velocity. That is their starting speed, right? They will always have initial velocity. Now, the moment they collide, all right, then there can now be at their collision, there's what you call impact. That is what you call impact, which is what happens here. Now, after this collision, it will definitely lead to somewhere. It's either they move towards one direction, something of this nature. Are you with me? Now, so which means their velocity now will be what you call final velocity, or you call it common velocity. All right. Now, why is it common velocity now? Because at their collision, they have met with each other, so they have to they have to move. Now, so their destination or going together means that they have a common velocity. All right, they have a common velocity. So if you understand that, then you will quickly need to understand two types of collision. Number one, you have elastic collision, and then you also have inelastic collision. All right, inelastic collision and elastic collision. Now, what do we mean by elastic collision? Elastic collision simply means both energy and momentum are conserved. Now, what that means is, watch this carefully. If the two bodies jams together, collides together, right? What happens in elastic collision is that both energy and momentum is conserved. That is elastic collision. That is, even after their impact, nothing changes. Their energy is still conserved. The momentum is also conserved. Now, so, and you already know what momentum is, and you know energy is the capacity or ability to do work, and then you also know that momentum is the product of mass and velocity. Good. Now, if you understand that, let's go to inelastic collision. What does inelastic collision mean? It means that momentum is conserved, but energy is not conserved. Momentum is conserved, but energy is not conserved. In this case, both energy and momentum are conserved. Now, but in this case, only momentum is conserved. Do you get that? Now, so if you understand this carefully, then I can now introduce to you a particular formula. So in this section, I'll just introduce one formula particularly that talks about the principle of conservation of linear momentum. The principle of conservation of linear momentum. So I will be using this particular image here, right, to explain the principle to you. Okay, so let's just bring out the principle. We have m1 v1 minus m2 v2 equals to m1 v plus m2 v, which is equals to, right, in this case now it becomes m1 plus m2 open and close bracket v. Now, therefore, we can simply say we now have v equals to m1 v1 minus m2 v2. Are you following? Now, in this case, now what we just simply did was that we are going to be dividing both sides by the coefficient of this, so that we can make v the subject of the formula. So we can now have as m1 plus m2. All right, now this is a particular section of the formula. Now, another particular formula that will be so relevant to what we are doing could be m1, are you there, m1u equals to open bracket m1 plus m2 close bracket v. Now, this kind of formula is when we are actually calculating for the common velocity. So when you are calculating for common velocity, you use this kind of formula. So in the next section or in the next video, I'll be teaching you or giving you an example using this particular formula for calculating common velocity. Now, so today you have learnt on collision, collide, jam, hit. When two bodies hit together, we have before collision, after collision, and during collision. And I talk about common velocity of the collision or the effect of collision. And then we also talk about elastic collision, which is energy and momentum are both conserved. In the case of inelastic collision, momentum is conserved while energy is lost. Please kindly subscribe to this channel. As you do so, God bless you.